All right, we're going to talk about section 12.4 today, which is talking about the positions of the different shapes. So what we're looking at is, instead of trying to figure out like information about the center or information about how it's dispersed, we're looking at just strictly, if the numbers are in order, what is the relationship of the different numbers by position. So some of the things we're going to talk about are z-scores, percentiles, deciles and quartiles, and something you might be familiar with called box and whisker plots. So again, we're looking at all of the data as a collection. We're putting it in order. We're trying to figure out how the data is related to each other based solely on position in the set of data. If it's in the middle, we're sort of figuring the median, things like that. So the first thing that we're going to look at is something called a z-score. And a z-score is measuring how far away something is from the mean. And so when we're looking at the z-score, if something's extremely far away from the mean, that's a good chance that maybe that's an outlier. If you're comparing two things that are not too far away from the mean, then you're going to say the one that's farther away is either better or worse, depending on whether it's farther away in which direction. So here's an example where we have two students, Jen and Joy, and we're trying to figure out what their z-scores are. So Jen's score on the test was an 83, and Joy's score on the test was a 78. So if we do our z-score for those two grades, the 83 is Jen's minus the average of her class, which is 78. So the 78 that you see here is the average score in Jen's class. It has nothing to do with Joy's grade. So the 83 minus the 78 divided by Jen's standard deviation, which is 4. And then Joy's class, you're going to take Joy's score minus the average in Joy's class, which is 70, and divided by 5. So what you find out that in Jen's class, her standard deviation, or her z-score, was 1.25, and Joy's z-score was 1.6. So because Joy's z-score is higher, even though she scored lower on the test, she did better than Jen did in terms of her class average. So one of the things that we can also do is take percentiles, and that's when we figure out, like, the 50th percentile would be the halfway point, or the 60th percentile would be above the halfway point. The 30th percentile would be at the 30th percent. So to do that, you're going to take whatever percentile you want and multiply it by the set of data, and that's going to tell you what the position of the percentile is. So let's look at this and get a clean slate here. It's not going to let me clean this off. Okay, so here we have the 40th percentile. So to get the 40th percentile, we're going to take 0.40 and times the set of data, and that equals 12. So if we count 12 positions over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The next position denotes the marker for the 40th percentile. So the value of the 40th percentile is everything below 75. If I looked at, for example, the 30th percentile, I would multiply 0.30 times 30 sets of data, which is 9. So again, counting over 9 places means that this 72 is the marker for the 30th percentile. So anything below 72 would be in the 30th percentile. So when we're talking about deciles, which is just another term, we're talking about dividing the set into sets of 10. And quartiles, we're talking about dividing it into 4 equal parts. So for deciles, I could do 0.10 would be 1 decile, 2 deciles would be 0.20, Quartiles, we're going to talk about another way in a second, but quartiles could be 0.25 or 0.50. So if I want the sixth decile, I want 0.60 times 30, which is 18. So counting over to the 18th spot, 16, 17, 18. This is our marker for the 60th and the 6th decile. So 82 and below would be the values that represent the 6th decile. So here's what we're going to do for quartiles instead of doing the 25%. The second quartile is the median. So we're going to find our position of our median by doing the n+1 divided by 2 to figure out our position. Then the first quartile is the median of all the items below the first quartile. So we're going to figure out how many items there are below the first quartile, and then again we're going to do n+1 divided by 2, but the n value is going to change. And then we're going to do the same thing for the third quartile, but we want the values above quartile 2. So let's look at this one. So we're going to find our median first. So there are 30 sets of data. So the median is going to be 30 plus 1, so it's the 15.5 position. So the 15.5 position is 78 to 79. So we find the average of those two numbers, and quartile 2 is 78.5. Okay? So that's quartile 2. To find quartile 1, we're going to look at these numbers that are outlined in red here. Let's see if we're going to get a highlighter. We're going to look at these numbers right here. And when we look at those numbers, there are 15 of those numbers. So we're going to do 15 plus 1 divided by 2, which is 8. So the 8th position over is 72. So 72 represents quartile 1. And then we're going to do the same thing for the other set of data. Let's go back over here and get a highlighter again. I'll get a green one this time. So when we look at this set of data, we're looking at this set of data right here. And again, there are 15 sets of data there. So we're going to do 15 plus 1 again, divided by 2 equals 8. So in this case, the 8th position from the beginning, 1, 2, 3, 4, 5, 6, 7, 8, would be the number 88. So 88 is in quartile 3. So with the quartiles, what we're doing is we're trying to figure out where in the list are the 4 different dividing points. So we've divided our list into 4 parts. The first part is denoted by everything below 72. The second part is denoted by everything between 72 and 78.5, which doesn't actually exist. And the third part is everything above, between the 88 and the 78.5. And the fourth quartile, which we haven't actually identified, is everything above that 88. So what we do with this information is we can use this information to calculate what we call box and whisker plots. Here's just the answer. We can do something called box and whisker plots, and this just gives us a visual of the dispersion of the different set of data. So in order to know this, I have to know the median. I have to know what is the first and the third quartile. So I have to figure out my 3 quartiles there. And I have to know the range of numbers. And the range of numbers, remember, is just the difference between the highest and the lowest number. And we're going to put all of this into a visual display. So let me explain this to you. So we're going to go through and find all of our data here. So the first thing we need is quartile 2. So quartile 2 is the middle of this set of data. So there are 20 sets of data. So if I do 21 divided by 2, I'm going to get 11.5. So I'm going to take the value of the 36 and the 37, and I'm going to add them together and divide by 2, which ends up with 36.5. And that's the value of quartile 2. So quartile 2 is sitting right here between these two sets of data. So to find quartile 1, I'm going to take the numbers to the left of quartile 2, which is 10 sets of data. So I'm going to end up with my quartile 2 being at the 5.5 position. So it's going to be between these two. So quartile 1, I think I said quartile 2, is going to be 28 plus 29 divided by 2, which is 28.5. And quartile 3 is going to be the same idea. There are the same thing. So we're going to end up taking the 47. Quartile 2 is, I'm sorry, quartile 3 is between these two. So 47 plus 49 divided by 2, which is 48, and that's quartile 3. So now we're going to take that data and put it into a picture, and this is what we have. Quartile 1, we always have this basically a number line at the bottom. Quartile 1 was 28.5. Quartile 2 is this dotted line, and it's 36.5. Quartile 3 is the 48. And then the end of this number represents the lowest value in the range and the upper value in the range. So the box part of the chart is formed by the quartile 1 to quartile 3, with the median specified in the middle with the dotted line, the lower range number and the maximum range number with the lines coming out of the box and whisker. Okay, so again, this is the minimum value in the list, and this is the maximum value in the list. And so that shows us the range of numbers that we have there. All right, I hope this helps. Keep in touch. Let me know if you're having any problems. I hope you're having a great week, and good luck on this material.